Okay, we are almost ready to start again. I hope you all had a chance to get a beer. Cheers. I hope you had a great day. So you are now part of an experiment. So because the first time we tried to do a keynote without any chairs was in Amsterdam 2 years ago. And it was because Linda Rising, one of our favorite speakers, she just told us about a study that you learn much more if you stand up. So those of you who stand up will learn much more the next hour. Those of you who sit down, you will gain weight because you have a beer in your hand and you don't spend a lot of energy because you're sitting down. Your brain will start sleeping and it's really bad for you. Those of you who stand up, you will use more energy. You will come out more fit, live, and brighter and more clever. So you have the choice now to just sit down or stand up. The other thing that we noticed the first year we did the stand-up keynote was that nobody really dared to enter the room without chairs. The first guy entering, he was like running out again. There's something wrong here, there's no chairs. There's normally a chair. Eventually, we got everybody in the room. And it was very noisy because everybody started interacting and discussing and how was your day, and it was really a lot of noise. And I had a problem like now, calming you down and no, don't discuss. Now we have a lecture here. And today it was a mix. So it was not as loud as an empty room, but certainly much more noise than tomorrow morning when we have a keynote with chairs, because then you just sit down and you do your emails and you fall asleep again. So once again, you're welcome to come forward. There's nothing dangerous on this floor up here. And please stand up if you want, if you can. We have a few disabled speakers, or at least one. He can sit down. I'm talking about Michael Hunger. But yeah, this is much better. You will learn so much more if you're here. And with these words, I'd like to introduce Trisha. And she is also one of our favorite speakers. And I hope you're not going to explain why it's better to sit down. Please welcome Trisha.
Hello, good evening, everyone. This is the first time I've given a presentation where everyone was around the edges as if they were terrified of me. And it's a bit alarming being all on my own, so do please come and join up these very brave souls who came to lead the charge to the front of the room. And if I see you using your laptop or your phone other than to take photos, I will make you come and stand here. So it's up to me to make sure that you guys are fully entertained because you don't have anything to distract yourself, and in which case all of your attention is on me, which is simultaneously amazing and extremely terrifying. Anyway, I'm Trisha. I'm a Java developer for MongoDB, and I am not a consultant or a contractor, so I'm not here to sell you my services. I am also not yet an author of a book, so I'm not here to sell you my book. What I am going to do is I'm going to share with you my experiences of this challenging thing of trying to stay ahead of the technical curve. I do go to a lot of conferences, so I do hear a lot of new technologies, and I kind of have to decide which ones sound really interesting and which ones I'll just have to leave for another day. So the aim of this talk really is not like, I'm not here to tell you which technologies to use right now, which technologies are the most awesome, obviously MongoDB, obviously, but I am here to tell you, please, whatever you do, try not to rip out your existing technology stack as soon as you get home and put in all the new stuff you heard at this conference, because that never, ever works, and I've done that, so take it from me. So the key thing from this conference, from this talk, is you're going to hear about, and you have already heard about, lots of really exciting stuff. You're hearing about microservices and usability and about continuous delivery and DevOps and all these things. And you're going to want to try them all out immediately, probably. And I'm going to tell you not to. So, having said that, we're going to move straight on to the technical part of this talk. Java 8 came out this year. Who's a Java programmer? Quite a lot of you, yay. Who's using Java 8? Okay, that's good, because I'm going to teach you about Lambdas, and those of you who are already using it know this stuff already. So we got Lambdas this year. Everyone else who is not a Java programmer is laughing at us because they've had Lambdas for ages. We had Lambdas. They were called anonymous inner classes, and they were 15 lines long. Now we have a shorter version. So I'm going to go straight in, and I'm going to show you an example of where I had some real code, and I wanted to Java 8 it. So I wanted to shove Lambdas in there, like, wherever I could find a spot for them to fit. And so this is a real bit of code from a demo I give at a bunch of other conferences. And what it does is it's quite straightforward. It's just like a save order method. And it takes an order object. And there's some case where maybe it returns some sort of error response, and some case where it returns some sort of success response. So I thought, fine, I can turn this into like an error handler and a success handler, and then I can Lambda it, and that's all going to be good. So I'm just going to refactor this. Oh dear, this is not starting well. I'm going to refactor this so that it's easier to put this into a method. Let's extract this out into a new method. Let's call it save. Okay, and let's make sure we can see all of this. Let's take the success response here, and instead of returning the success response, let's do success handler dot on success. Live coding. It's like pairing with 300 people looking over your shoulder. Don't look, it might go wrong. Okay, so let's refactor that, pull that into a parameter. Let's create this success handler thing. It's going to be an inner class, which I'm going to turn into an interface, because our Lambdas are single abstract method interfaces. So I just want one single method on this interface. I'm going to tell it it's a functional interface. So I can do Lambdas. That was nearly a very bad typo. And then I can pass in, as my success handler, I could pass in a new Lambda. Now, I don't really know anything about Lambdas yet, so I'm going to pass it in as anonymous inner class. This is the same code we had before for our success. Let's return that. And then let's just get IntelliJ to lambdify it for us, because I don't understand Lambdas yet, and IntelliJ does. Magic. So let's do the same thing with the error response. Cut that, error handler. Oh no, handler on error. Pass this in as a parameter as well. Do that. And try not to get IntelliJ to be too keen. Create an inner class here. This is going to be an interface as well. It's all the same thing as before. Perhaps I should have scripted some of this so I don't have to type it all wrong again. Functional. Let's give it an onError method. And then when we call the method, same thing. We need to create a new error handler. Pass in the response that we were doing before. Return. Get IntelliJ to turn it into a Lambda magically. And ta-da! I've Lambdified my method. So I've used a new feature in Java 8 which makes the code shorter and more readable. So this is 51 lines of code, and the original one was 31 lines of code. So I'm going to say that maybe, that's not quite what I was going for. I did successfully lambdify my code. Did I make it more succinct and more readable? Probably not, let's face it. Okay, so enough of lambdas. Let's move swiftly on to another feature of Java 8, which also came in this year. So with new Java 8 collections, you can actually do operations on collections in parallel. You can use this magic incantation to say, I want to do this operation on my stream in parallel. And then this way, I don't have to worry about going multi-threaded, about doing anything complicated around concurrency. I just tell my data structure to process itself in parallel. This sounds like an amazing thing to do because most computers are multi-core. Even my phone's got multiple cores. So we want to be able to go parallel so we can do these operations on multiple cores and get the benefit of our multi-CPU processors, multi-CPU environments. So let's do this. I've written a performance test. Is Martin Thompson in the audience? I really hope not, because I don't want him to see this. I have written a very naive performance test. It's very clunky. And the aim of this is, I'm going to do something fairly simple. I've got here a list of coffee shop objects. I'm loading them from MongoDB. I've got 46,000 coffee shops. I'm going to put them into a list. And what I want to do is I want to use the new map function on our streams interface to get the name and put it into a list of coffee shop names. For all 46,000 of those coffee shops, I want to get a list of all 46,000 coffee shop names. Okay, so I'm using the map function for that. And I'm using streams, so this is going to happen in serial. So we're going to run this performance test live. What could possibly go wrong? I'm going to run this performance test live, and what you should see is, this is my CPU activity up here, so I've got 4 cores, I've got MacBook Air, and you'll be able to see it doesn't use all 4 cores thoroughly, and you'll be able to see how long it takes if you're doing it in a traditional serial way, assuming nothing goes wrong. I'm not using the Wi-Fi, so that's got to be one advantage. All right, let's bring up the activity monitor. So this is going to warm up. And we can see when this settles down, this is using about 100-ish% of the CPU. We're not using all of our cores here. Yeah, we've settled down to 100% of CPU. And we're going to process this in a serial fashion, all 46,000 of these coffee shops. And when we look at it, it takes about, on average, 0.7 seconds to do each one of these operations. Okay? So let's look at the same thing if we go parallel. It's exactly the same test. We have a magic incantation of parallel stream instead of stream. We're doing exactly the same thing. And what we expect to see is we expect this to run much faster, obviously, but also to utilize more of the CPUs available. So we'll run this and bring up our activity monitor again. Deathly silence. You're waiting for it to go wrong, I know that. So we're going to warm the thing up. We're starting to see the usage of all the cores. Java's now taking 296%. Okay, so it's using much more of the CPU power available on its poor little tiny MacBook Air. And it takes 0.6 seconds. So it's marginally quicker, okay? It kind of did what it says on the tin. It went parallel, it used all the CPUs available, and it provided the result in slightly less time than a serial fashion. That's good, right? We want to go parallel to get faster. Now, that works really well when you have a lot of data. As I mentioned, there's 46,000 coffee shops here. And it works well if you're processing every single one of those pieces of data. What we're going to do here is use a slightly different function, anyMatch. So if any coffee shop of these 46,000 coffee shops is called Starbucks, and let's face it, there's a fair chance that one of them is called Starbucks, then it will return true. So the thing I return is just a Boolean, not a new list of all the coffee shop names, but just a single value as soon as it finds the right thing that matches that criteria. Now we're going to do this in serial, so we're going to use just stream, not the parallel stream. Let's find out how long that takes. I'm not going to bring up the activity monitor because it shouldn't take too long. 30 milliseconds. So yes, not surprisingly, there was a Starbucks in my data set, and it took 30 milliseconds to process 46,000 coffee shops in serial. So let's do the same thing with the magic parallel stream here. Let's run this. And let's see how much faster this goes. It takes 118 milliseconds. So it takes, what did it take before, 19? How much? 30. And now it takes 118 milliseconds. So going parallel in this case has slowed down the performance of that operation. Because all you're doing is trying to process it, find the first one that matches it, and then return. If you're going to have to spawn off separate processes and split up your data and then rejoin them, it becomes much more expensive. So this is not a magic incantation to use in order to get better performance on operations you're doing on your data. So what exactly have I just shown you? I've just shown you two new amazing features of Java 8 that are going to make our lives easier. We're going to have more succinct code with Lambdas and faster code with parallel. And I've just shown that's not really true. So what's the point of Java 8? That is a totally different thing altogether. The point is, what we need to do is we need to figure out why we are trying to implement this particular thing. Why are we using this feature? Why are we using this language? Why are we using this framework? All the stuff that you're going to hear about and have already heard about in this conference, instead of just running straight off and going, MongoDB is amazing, I should definitely implement it, which you should. Instead of doing that, you need to step back and think about, what is it I'm trying to achieve by learning this technology or process or framework or language? There are 3 reasons I can think of why you might want to learn a new technology at a very high level. The first of these is for the business. Now, the business, they're the guys who effectively pay us. They're the guys who are always asking for something else, right? Can you do this? No, I can't do that. I need this now. I can't really do that in my existing infrastructure. And often they'll be asking us for things that maybe are difficult, time-consuming, or maybe even impossible to do within our current frameworks, our current technologies, our current processes. So a lot of these new things that we hear about are ways to enable the business to make more money, which is good, because then they'll pay us more money. This is a good thing. So they might want to do something like, they might ask us for customizable, flashy dashboards, and we don't really know anything about this because we're server-side Java developers. Or they might ask us, they might tell us they're going to go live in China now because China's a massive market, and that's kind of in the window where we normally do our releases, or we normally do our massive batch processes, which take ages, or that's the downtime that we need. Or, and this has been common for years, you might be trying to store different shaped data in a single table in your database. So how many people have worked on systems where they had tables that looked a bit like this? So this is the real data, this is the coffee shop data. But I worked at Ford Motor Company, I've worked in investment bank, and we always had tables like this, where you're trying to squeeze products that are not quite the same shape into the same database table. So like a Ford Mondeo does not have the same characteristics as a Ford Transit van, for example. Foreign exchange instruments are not the same shape as equities. And you end up with this kind of super denormalized data where everything is kind of null. There's no safety at all on the different types. And you don't get any of the actual benefits of having a relational database. So now you've got some business problems that you need to solve. There might be some technologies that you've heard about at a conference like this, or reading blogs or on Twitter, that seem like they might solve that particular problem. So our shiny dashboards, maybe you want to investigate HTML5 and JavaScript and Angular and all those cool things, Bootstrap. If you're having trouble with your deployments, for example, then there's loads of stuff that you're hearing about at this conference that might help ease that pain of deployment, if that's the thing that you're normally doing in that window. And obviously, in the case of our massively denormalized data, a NoSQL database like maybe MongoDB might be the right thing for you. So in MongoDB, this is the same coffee shop data, and it's stored effectively as JSON objects in the collection. And you could probably see the coffee shop at the top is much smaller, has far fewer characteristics than the coffee shop at the bottom, and they all live in the same collection, they all live happily ever after. And it's kind of down to the thing which queries the data to figure out what to do with it. So it's much more appropriate for this kind of fluid, dynamic schema, if you like. So if you've identified a business problem that perhaps needs a new technology to solve it, there are many different approaches you can take in order to try figure out whether this is the right technology for you. Because it might not be, which is the important point, really. If you're trying to solve a particular business problem, there's all these things. So let's talk about spikes and prototyping. Normally, I know that we've never seen this, but normally with spikes and prototypes, normally you throw the code away. You don't put it into production because it more or less does what you thought it was supposed to do, right? People are there going, yeah, I've done that. So the idea behind a spike is you take a week or however long, you have very specific questions to answer during that period of time, and then you basically ask, does the technology answer these questions? Does it fix the problem? And often you go, yeah, it sort of does, and I spent a week working on it, so we might as well use it, right? Whereas in actual fact, yeah, it sort of does, is not quite the right answer. You might want to try it with 2 or 3 technologies, which seems like a waste, but it's not, because that allows you to pick the correct technology. And maybe next time you have a business problem, maybe one of those discarded technologies from that spike, maybe we pick that later. It's not a waste to do something and learn it's not the appropriate tool. That's a very valuable learning exercise. So there's other things like if you want to use a new language, for example, Java 8 and Lambdas, you can use those in test code before you start shoving it into production code. There's lots of code in things like build, deploy, continuous delivery, pipeline systems, which you might have a bit more control over. So you can try out new technologies in that area. Internal tools, you might want to try something out either in some sort of dashboard that's facing your team rather than going straight to some business-facing or even external-facing tool. Often, if you're used to creating very small projects, you might be able to try out a new technology stack on a new project. I'd suggest perhaps taking one of the earlier steps first before creating a new project in the new technology. But that's down to you. Use at your own risk. And if this is a business problem which is going to genuinely change the business, if it's something that is going to make them more money, or, well, that's really all they want, really, isn't it? More money? If it's going to make them more money, if it's going to be a market changer for them, then we can invest some money in getting in some experts. So maybe get some people on site to train the team in a technology. Vendors like ours and a bunch of other vendors, we will send in consultants to work within your team and tell you whether the technology is the right choice or not. And we do often say, no, don't use this technology. Like anytime anyone wants to do like a graph thing with MongoDB, we tend to say, go and look at Neo. It's going to be much better for you. I knew you guys were here. Because if you try and map graphs in MongoDB, it's just going to be an absolute disaster. It's not a good thing to do. So get the experts in, maybe even get someone like ThoughtWorks in and get your guys embedded in their team and share and spread some knowledge, because those guys have done this before and you guys haven't. So I have no services of my own to sell, but people out there know how to do this stuff, and if it's going to change the business, it's probably a good idea to spend a little bit of money getting that expertise in, but sharing it with the team and upskilling the team. Because I've also seen consultancy teams and contractors come in, be hired to implement a specific thing, and then bugger off and leave it behind, and you are having to pick up the pieces and figure out how this thing works, and then you re-implement it in some new technology that takes your fancy. Anyway, right, point 2. I apologize for talking too fast. As usual, I have drunk far too much coffee. That coffee outside is really good, right? It's awesome, isn't it? You guys are twitching as well. Reason 2 for learning a new technology. Your team is feeling some sort of pain. There is something which is slowing you down or causing you to have to work weekends or get phone calls at 3 o'clock in the morning. These are things that do not often get prioritized for the business because they don't directly make money for the business. So let's see, things like you've got a mixed team with a bunch of different programming styles, maybe some people doing more old school, traditional OO with older versions of Java, some new functional hipster type people doing functional hipster stuff. And maybe it's difficult to communicate between those different people, those different projects. Maybe your releases are painful. I've mentioned releases a bunch of times because this is the sort of pain that I've been through so many times. Maybe your releases are very painful, they take a long time, and you're the one who has to do the releases on Saturday morning, not the business, so they don't care as long as it gets done. Database schema changes might take ages, so applying a new column for some people might take hours out of their release cycle, or even, in some cases, it can take weeks to apply a new schema change to a massive archive of data. A particular pain point that I've had over the last couple of years in this current role is I'm very keen on the BDD style way of doing automated testing. I really like that kind of, this is my setup, this is the thing I'm actually testing, and these are my assertions. And we had a much more flexible approach to testing when I first joined there. The fact is we actually had good automated test coverage, which is fantastic. But sometimes you go back to a test and if you can't read it or understand it or figure out what it's testing, like maybe this one, then you start to wonder what the point of the test is. So this is actually, you can have a look at GitHub right now. This is a real test that's in GitHub right now for the MongoDB Java driver. It does test things, so it proves the Java driver works. It's just me being anal about how my test should look. But the point is that you can figure out, even if you can't read it, that this is testing more than one thing. The fact that the word assert appears multiple times throughout the test is a good indicator of this. Also, further down, you get this idea, oh, I've got a laser on this. You get this idea that we're testing, you can't see that, more or less the same thing with different inputs and different outputs. So it's the same steps, but with different inputs and different outputs. And this kind of offends me because I feel like it should be multiple tests. Because what happens if one of the assertions fails right at the very top, and then the rest doesn't get run? And we have no idea if that failure means everything breaks or just that one thing breaks. So there were a number of different things that irked me about this testing style. Also, and this is more of something I didn't really notice about Java until I started working with a document database. MongoDB effectively stores things as maps. Now, until I started working with MongoDB, I didn't realize how ugly maps are in Java. They're kind of icky. You have to do .add, and it looks like that, and it's all this text that's boilerplate, and it's not awesome. But that's more of a niggle than anything else. So I'll come back to that, obviously. So now that we've figured out that there are some things which are hurting the team, some things which hurt our productivity or personally hurt our social lives because we can't actually go out on a Saturday because we're doing the release again, there are a bunch of technologies which may or may not solve our problems. For example, moving to Java 8 or maybe Groovy might allow us to use multiple coding styles in a mixed team environment. Again, DevOps tools and processes might be a good way to take a look at our release process, throw it away and start again. No, never throw it away and start again. I've learnt that the hard way. Obviously, NoSQL solutions might be a good thing. If you're doing lots of schema migrations, then you're thinking maybe I actually have a more fluid dynamic schema than I thought, so I should move to something which supports a fluid dynamic schema instead of something which is very rigid and relational. And the example I wanted to point out is that modern test frameworks are quite good at allowing us to enforce things like better testing styles. So I was forced to go to a conference talk on Spock a couple of years ago. And I didn't want to use Spock because Spock is using Groovy, and I'm a Java person. I don't want to learn Java. It's a Java open source project. It needs to be read by Java people. And then I saw Spock, and I was like, I love Spock. I'm going to use it everywhere. So what I did is I did a week-long spike, where the question I was answering was, will Spock provide us with the structure we need around our tests to force people to think in this BDD style, and will it give us advantages as a testing framework? So this is the same test split into Spock tests. Obviously, there's more than one because that test was testing more than one thing. But the interesting thing is the second to last and the last tests, because here with Spock, you can define a series of inputs and a series of expected outputs. And your test sort of looks the same. All it does is do the find one, but it gets run multiple times with these different inputs and different outputs. And if one of them fails, it still runs all of the others. And for us, because we're a database driver, this was like a killer feature for us, because what we want to do is do the same operation with lots of different inputs and outputs. And this was the reason we decided to go with Spock. Not the fact that map syntax in Groovy is very pretty, much prettier than it is in Java, but it made our tests so much more readable, so it aided our readability, so it answered the question for our spike, and we now use Spock and Java, but we use Spock and Java for our tests. So if you've identified that you have a problem that affects your team, and you've identified a number of potential technologies that might help fix this, there's many of the same things that we saw on the earlier slide. There are some things missing off this slide. For example, if you want to try a technology out to fix a pain within your team, your development team or your ops team or whatever, I wouldn't try it out on a brand new production-ready project or on an internal tool that faces the business. I would try it out within something which works and impacts us so we don't negatively impact the business trying to figure out how to fix our pain. And the other thing I've added on the bottom here is, I don't know if you can all see that, but it says Skunkworks projects and hack days. So this is a little bit more, there's a number of different advantages of this, some of which I'll go into in a minute. But at MongoDB, we do Skunkworks day or 2 days, once a quarter. And largely it's a good way to play with technologies and see how they feel. Sometimes at the end of that, you might have a project which is useful for the team. For example, we were working on a new tool to track people like me who go off at conferences all the time. And we were working on tools to envisage this or dashboards for that. And you can get some useful tools, some useful improvements out of this sort of thing. It's sometimes a little bit of a difficult sell, but you're only asking for 1 or 2 days a quarter in order to reduce your pain and improve your productivity. So the third reason to use or learn a new technology. Feel free to move around a little bit, by the way, if your knees are starting to ache. Because look, I am moving around. I can move. You guys can move too. The third and most, in my mind, most compelling reason to learn a new technology is for yourself. You sit in one of these talks and you hear about this thing and you think, that looks awesome. I should definitely be using that. Or I want to, yeah, mostly that looks awesome and I want to use that. There are a number of different reasons, all the way from this is awesome, I want to use it, sort of through I want a new job, so I probably need some new skills in order to get a new job. Of course, no one here wants a new job, right? Because your employers all sent you out here and you wouldn't own up to wanting a new job, no. Some people want new jobs. Or it might be, I can see a niche in our organization where we're starting to use this technology, or we have been using this technology, and maybe I could become the technology guru because there's kind of a hole there for that expertise. And this is something I'm very interested in. Something I hear quite a lot, certainly from new graduates and also from people who've been doing the same sort of job for quite a long time, is this, I need to learn new technology because I don't want to be left behind. This sort of fear thing, as opposed to the sort of joy of, oh, reactive systems, they sound amazing. This kind of fear thing of, oh, crap, I don't want to be left behind. I need to learn stuff now. That's a valid option. I'll talk about that in a minute. So given that there are a number of different motivators, and given that the reason to learn is for you, there's also a wide range of places where you can figure out solutions that you're going to learn. So this is not the same as the previous times where I'm like, yeah, HTML5 will solve that problem, or NoSQL for this. This is totally open to your own interpretation. I heard about a new technology, it looks amazing, I'm going to learn it. I'm looking at job adverts for the next big job, and everyone mentions HTML5, and I don't know anything about HTML5. Obviously, you've got new technology coming into your workplace, or maybe you think that there's something which is being used but not used properly. There's always gaps there. And if you're kind of driven by fear, pretty much all of these are kind of weighing upon you to decide which technology you should be picking up because it's going to be the next big thing and you must learn it. So let's talk about that. This is code I wrote in 1998 or 7. Either way, it was one of my first Java applets. How cute. And it looks like crap, not because, well, partly because I don't know how to code applets and I was, only however old I was, but also because I'm using Java AWT. And AWT was, it did the job at the time that was required of it. Let's put it that way. So I was learning Java at university. I was playing with applets on my web page because I wanted interactive web page, and applets are the way to do that in 1997. I didn't discover JavaScript until 1998. And so I was playing with these things, and then I did my internship at Ford Motor Company. I did 3 months in the summer, and we actually had written a 2 meg applet. Now, I don't know if anyone remembers what dial-up was like back in 1998, but my job was to test the download speed for this. A 2 meg applet took 35 minutes to download. Yeah, I had a lot of time on my hands that summer. I did a lot of research, even though we didn't have the internet. So I was doing this project, we were working on this 2 meg applet, and one of my jobs was to try and figure out whether this new funky UI called Swing was going to benefit us, whether it was going to be faster to download for a start. So I thought, right, I've just spent 6 months learning Java AWT in applets, and I'm going to graduate in a couple of years, so I should probably learn this Swing thing. So I went away, I took an application that I'd written in Pascal for my father at high school, and I re-implemented it in Java, and re-implemented it with a Swing front end. I had to learn everything about, we were learning Java at university, but I had to learn everything about file handling because I was storing everything in files. I'd heard of databases, but I didn't know how to install it on my 386. And I didn't know how to get JDBC working, so I didn't use that. I used files, and that's fine, it worked. And I had to learn all about how to do a fully formed Java app just so that I could learn a new UI technology. And I successfully did this. Well, I say learn, and I say successful. I obviously didn't learn how to do layouts. I remember thinking for ages, I don't know how to get the labels to line up with the buttons, but I'm like, it works, it's fine. I rolled this out to my dad to his careers library at school in '99, and he used it until he retired about 3 years ago. Poor guy. I really feel for him. I nearly rewrote it in JSPs, but I was like, no, I've rewritten that twice already. I'm not doing it again. The point of this story is I spent about a year doing this on my spare time, in between homework, in between learning stuff. And then when I went back to Ford for my year out in 1999, so I'd kind of been doing this, the better part of a year, we were using Microsoft technology. We were using ASP, we were using VB, and this is pre.NET, by the way. So I didn't use any of my Java stuff that I'd learnt. And then when I graduated in 2001, we were doing JSPs and servlets. And in my entire career, since I did this in 1998, I have not used Swing once. Not once. And I invested a year of my time, my own free time, doing this to learn a technology so that I wouldn't get left behind. What a waste of time. So if you're learning something for yourself because you want to, or to advance your career, or for whatever reason, you actually have so many options of places where you can learn about this stuff. So I kind of ordered it more or less from kind of like lightweight approaches to sort of more heavyweight, fully invested approaches. And I put user groups at the top mostly because I helped to run 2 user groups, and user groups are amazing. But for me, user groups are a really good way to feel the pulse of the technical community. And I can turn up, have a beer with a bunch of people, hear what they're working on, hear the pain points, hear the things that are awesome, and then I can figure out which technologies I think I might want to invest some time in. So user groups are really awesome. Online courses, there's so much free education these days. At MongoDB, we offer a bunch of free courses for MongoDB with Java and Python and Node, and there's like a DBA course and all these sorts of things. Also, there's obviously Coursera, and there's like free university courses from Stanford. There's just so much free stuff to learn these days. Obviously, there's a classic of re-implement a pet project in whichever technology you want to work on. This, I think, is quite intimidating for a lot of people because you have to do the whole thing, like create this whole project end to end, which might not really be your thing. But I've spoken to a lot of people lately where they have their single, non-trivial but well-contained pet project, and they'll re-implement it in a bunch of different languages, a bunch of different frameworks. So then when they're coming on and trying out Scala, for example, they don't have to do the investigation of what is this thing supposed to do, what's the domain, how is it supposed to interact with users. They just re-implement the same thing in a different, idiomatically for a new language, which is quite a nice way, I think, of seeing the pros and cons of different languages and frameworks. If you don't want to do a whole project all on your own, then there's always joining an open source project. So for example, well, we've got an open source project, you can totally join ours. But if you wanted to learn Swing, it would be great to sort of jump into someone else's project and just work on the Swing stuff. You don't have to worry about all the other bits of the project. And also, you'll be working in someone else's code base, so you'll be picking up habits, good or bad, from someone else's code base. And hopefully, if you've picked the right sort of project, you'll be getting constructive comments from the maintainers of that open source project on how you can improve your code. So this is a lot better than kind of working on isolation on your own pet project. I looked at the code the other day for my Swing application. I will not inflict it upon you because you don't want your eyes to bleed. But yes, I learned a lot about how to use Swing. I didn't learn a lot about how to do object-oriented design. Never mind. I shouldn't admit to that. That was a long time ago. I'm much better now. Where was I? I've distracted myself. The next option is there might be projects at work you can lend a hand on. You could do this almost in your spare time at work, like an open source project, but like in-house, because there's always stuff that needs working on. We have projects inside our own company which are written in Java, and I've done a lot of Java stuff, so I could go and help them out with that stuff. I haven't yet, because it's based in New York, but I could if I wanted to help them out with new Java stuff. The kind of most extreme way of learning a new technology is get a new job in that technology. It is possible. I don't think we have the bootstrapping problem we used to have. I don't think you, before, in order to get a job in Scala, you had to know Scala, but you didn't know Scala because you didn't have a job in Scala, and it was really hard. But I think these days, more and more job adverts say things like, self-starter, hipster programmer, I don't know, what do they say? They say, motivated, polyglot, keen to learn, well-grounded, these sorts of things. So as long as you can program in one language, the expectation is you'll pick up the others and pick up new technologies. So the only thing I'd say about that is, if you get a new job which requires you to program in Scala, and you haven't programmed in Scala before, you might find yourself stuck programming in a language which is not really the language you wanted to program in. So maybe you might want to try out some of the other options before getting a new job to learn a language. Where are we? Oh, I've run out of time. I've been talking too fast and I still haven't got to the end of my slides. The key point here, when you're trying to pick a technology to invest your own time to learn, because if you look at this, almost all of these approaches require you to invest your own personal time to learn them. This is not the same as, I want to learn Scala, so I'm going to rewrite part of our core production code in order to learn Scala. No, that's not a good idea. You need to invest some of your own time in this stuff. So if you're going to invest your own time going to user groups or writing your own project or doing open source stuff, you need to pick something because you want to spend time on that. Because there's lots of technologies out there. You don't have to be an expert in all of them. You certainly don't have to be an expert in ones you don't like or don't care about. There's loads, so just pick something that you care about so that you can be bothered to invest your own time in it. And if you can't be bothered to invest your own time in it, that's fine. But now just admit the fact that you're not necessarily going to upskill except for inside your own work environment. And that's okay as well, just accept that. Most of what we've talked about when I was talking about the business or teams requiring new technologies to solve a particular problem, that's kind of, my house is burning down and now I need to do something about it, right? That's like, quick, the database isn't scaling. If we swap in MongoDB, will that help? No. Not if you don't understand the technology. I mean, you saw what I did with the parallel use case, right? I put in parallel so it should go faster, and it didn't. And if you don't understand the underpinnings of the technology or feature or language, it's almost definitely not going to end well. So organizations can be proactive to kind of help prevent this kind of everything's burning down, quick, swap in a new technology thing, and then you've got at least two problems. So there are things you can do. I mean, as developers, we're totally on board with all of these things, right? But our organizations are a little bit less keen to perhaps waste time doing hack days and skunkworks projects and 20% time and things like that. But these can be more or less heavy or lightweight or time-consuming as you want. So for example, I'm just going to point out the user groups thing again because I help to run 2 user groups. We have a problem all the time with venues, but if you wanted to say, if you're an organization and you want your developers to become more skilled, and one of the ways you want them to become more skilled is perhaps by attending user groups, instead of forcing them to go to user groups on their spare time, which is not a very good idea, if you offer to the user groups to host things on site in your office, that's a good way to, your developers will just accidentally slip in there, especially if there's free beer. You don't have to bribe them too much. And you'll also have this flip side where you'll get sort of smart people coming on site to your office, and maybe that's good for recruitment too. So, and that's a really lightweight way of helping your developers to become upskilled in their own time, a fairly minimal outlay for the business. And then once you see that sort of thing working, maybe you could start introducing things like brown bags at lunchtimes, and then maybe you might sneak in, probably not 20% time because they're never going to go for that. But and it's mythical as well. I mean, has anyone really done 20% time? But skunkworks projects like 1 day a quarter, I'm starting to hear of big investment banks doing this now. So if the big investment banks are actually allowing their developers to not work on their work, then this sort of thing is starting to pay off for these large organizations. So lots of organizations don't like this because they're worried if I invest time, well, mostly time and money upskilling my developers, they're going to up and leave. And that's not necessarily the case. The benefits far outweigh these risks. So obviously, you invest some time in things like Hack Days and Skunkworks projects and user groups and all these things. Your developers will become more skilled, theoretically, right? Because we're all smart people. They'll become more skilled. They'll be able to implement stuff better. Also, they'll get more skilled in a different range of technologies. So when a business problem comes along, there will be some developer who goes, oh, right, a NoSQL database is the perfect fit for this problem, and I know because I worked on it over here. Or, okay, you're working on a new HTML5 dashboard. I was playing with Bootstrap and stuff, and we should probably use that. So this way, we can pick the right technologies at the right time and stop this kind of twofold problem of, my house is burning down, and now I have a new technology that I don't understand how to use. But most importantly for us, this sort of thing will give happy developers. Happy developers like to spend a bit of time playing. They like to invest in their own learning. They like to be given a tiny break from the day job, which by and large we kind of like, just to play with something a bit new. And if you're giving that to developers, giving that to us, we're not going to leave your company. You're giving us exactly what we wanted. So you're not upskilling us so we can go somewhere else so that we can do Scala 100% of the time and find out that's not really what we want. We're going to prefer to stay somewhere where you're investing some time in us to play and investigate new things. It should be a mutually beneficial arrangement. So I've reordered my slides and now I've got no idea where I am. This is, oh, you can actually read that, I'm amazed. These slides are going to be online, so you don't need to worry about it too much. But I've kind of broken the approaches down a little bit into, I'm going to turn my back on you, I'm sorry. At the top, we've got for the business, then in the middle, we've got for the team, and then down here, we've got for you. So there's sort of three main reasons to learn and use a new technology. And we've got all these different approaches here. There's a certain amount of overlap between the technologies for the team and technologies for the business. You know, there's a reasonable amount of overlap there. This is kind of at the top, it's kind of most risky, like new projects. And at the bottom, it's kind of most proactive with like 20% time as Skunkworks projects. What you'll notice, though, is that approaches for learning new technology for yourself doesn't overlap that much with approaches for implementing new technology in business. So if you want to learn something because you want to learn it, you're going to have to invest some of your own time in it. And I hate saying that because it feels like we should be allowed to be trained up in our day job, but that's not the way it works. If you find something that's cool and is not currently used at work, you need to invest some of your own time in it, if that's what you want to do. And you don't have to. So yeah, I mean, there's a little bit of overlap here, like work projects and stuff like that, but there's not that much. So, more or less in summary, but I believe I still have more slides, of course. So you think I'm standing between you and more beer. I haven't had any wine yet because I didn't want to have any alcohol before I gave this talk. So I'm desperate to get to the end so I can have more wine. So, what can I do? Back to us as developers. When we are sitting in these talks and we hear about reactive and we hear about microservices and we hear about DevOps tools and we hear about Java 8 and we hear about all these things which sound cool, we should be thinking about, why is it that I want to learn this technology? No, I knew I'd reordered this wrong. We should be thinking about things I'm going to tell you about in another slide. Firstly, though, most importantly, don't panic, okay? There are lots of technologies out there. They come and go. They ebb and flow. I mean, I learned JavaScript in 1999, and then I thought it was dead in 2005, and I learned GWT and a bunch of other stuff, and now I'm back learning Angular. And that's fine. I don't feel like, oh no, I've got like 5 years of gap in my JavaScript knowledge. You just pick it back up. If it comes back into fashion, you pick it back up. It's fine. And if JavaScript had died in the meantime, then it would have been pointless me trying to stay ahead of the JavaScript curve when I wasn't using it at work, because then I wouldn't ever use it at work. So technologies ebb and flow. If it's here to stay, you can pick it up again later. You don't have to learn it now. And if it's not here in a year's time, there's no point in wasting your time on it right now if you're not using it right now. So don't panic about all these technologies which are being thrown at us. But if you do want to use something because it's cool, it's exciting, or whatever, you sit in a conference talk, and you hear about this thing and you want to learn it, think about why you want to learn it and implement it. So is it because it's going to solve this business problem the business has already told me they have, or I can just feel that they are going to have, or that they definitely have, but haven't really realized yet. So is it going to solve a business problem? Is it going to ease some of my pain as a member of my team? Is it going to be helpful for my team or a larger department? Or is it just cool and I just want to learn it? Or is it just that I want to level up and move on to a different job? Now that you know why you want to learn a technology, then you can select the technology, and that's the topic of an entirely different talk, and I decided not to touch that with a barge pole. But select a technology randomly, because, why not? And then use one of those approaches in that mind map to test it, to figure out whether this is the right thing for you. And ask, does it actually address the problem I was trying to solve? Because there is this worry, once you've invested some time in learning a new technology or implementing it in some pet project or some skunkworks project or spiking or prototyping, there's this concern that I've wasted all this time learning this technology, I should go on and use it. So that's not true. If it doesn't address the problem, go back, reselect, retest. Because this way you're just going to save yourself a lot of pain in the long term. If it does address the problem, then you want to level up. So you want to pick perhaps one of the other approaches, keep using it more, keep expanding it, teach other teams, and that sort of thing. So find out why you want to learn it, select it, test it, discard it if it's not the right approach. Otherwise, sort of iterate and keep getting better at that particular technology. Right, so earlier on, I showed you implementing Lambdas in my code. And I know that you're all dying to see what the right answer of that is, right? You all forgot. You're like, Lambdas, what are they? I'm going to show you anyway because it's my talk and you're just going to have to listen to me. I can see people sneaking out the back. They're like, there's beer out here. So let me show you the right way to right way to write this particular method. And I'm going to do that by going right-click, git, revert. Revert. Ta-da! Perfectly readable code, 30 lines of Java, and there's no complicated stuff there. If I should see this method again and again, and the only difference is the return values, the error and success, then maybe I might want to refactor it into using something like Lambdas. I didn't even need Lambdas. I could have just passed in a response, which is an error response, and a response, which is a success response. So this is the right way to solve this problem at the moment. And then, now that I've done that, that is the end of the presentation. The slides are available here. I've been Trisha G. Thank you very much.